My new star dataset. Right.
Hi everyone, thanks for joining. So the problem we are tackling is genuinely relatable. Newcomers to the United States may encounter challenges across many areas of daily life, from immigration and healthcare to taxes and beyond. The information is spread across many agencies and organizations. Some of them provide AI assistance and others do not. But even an agency-specific chatbot helps only after the newcomer knows where to go. And because rules and procedures change, assistance must stay connected to reliable current information. NewStart AI is our vision for one coherent front door. A newcomer submits a question, message, letter, or form. A routing agent first identifies the need, then forwards it to the appropriate specialized agent that we have created beforehand for focused guidance. Building that full ecosystem is beyond this capstone, so our MVP tests the first essential layer. Routing government document. Among here just 4 agencies that we brought: USCIS, the California DMV, Social Security, and IRS. We compare local BERT and LLM and NLLM with RAG to identify the most reliable and practical routing approach. This is a pipeline we built for that front doors MVP document come in, get classified by one of 3 methods, and then result routes onward to agency specific guidance. That's the whole system is you can see in one picture, and that's what the rest of this talk walk through. Now I will hand it over to Gaius, my teammate, who will talk about our project's dataset.
Hi, my name is Jeffy Thomas, and I'm going to be briefly going over the data set that we built for this project. So our data set consists of 754 publicly available government forms. We collected these from 4 agencies, including the USCIS, California DMV, Social Security Administration, and the IRS. Now, as you can see from the chart, the largest portion of our data set comes from the DMV, with 277 documents. This was followed by the USCIS with 256. The SSA had 198, and the IRS had 23 documents. So there is a noticeable class imbalance, particularly with the IRS. Those documents make up only about 3% of the data set, compared to roughly 27 to 37% for the other 3 agencies. This is an important consideration because a model could potentially perform well overall while still struggling to correctly identify the smaller IRS class. We also had some differences in how each agency publishes its forms and metadata. So we standardized those differences into a common format so that the documents can be combined into one data set. One particularly positive result from our pre-processing was that all 754 documents had successful text extraction. So we didn't have to remove any documents because of failed text extraction. Overall, we ended up with a data set that was large enough to test our classification approaches while also giving us some important data quality considerations to account for during modeling and evaluation. Next up, what does the data look like? We performed some exploratory data analysis to understand what was actually contained in these documents. So first we looked at document text length, shown in the box plot on the left. There was substantial variation between these agencies. The USCIS and IRS documents generally contained longer amounts of text than the DMV and SSA. One reason is that many of the USCIS and IRS forms also included multi-page instructions on top of the actual application or form. Now, we kept these documents and outliers because these types of documents occur naturally in the real-world data that our system would encounter. It's important to note that text length and page count were also used for data analysis and quality control, not as direct features for classification. Our models were ultimately classifying the extracted document text. On the right, we also look at the most common words for each agency after removing common English stop words and generic government terminology. And we saw some pretty clear differences. The DMV documents were characterized by words like vehicle, state, code, section, license, and driver, while the IRS was filled with tax, income, filing, instructions, amount. And the SSA notably had Social Security, benefits, federal child, as well as some Spanish words. And the USCIS was filled with words like application, evidence, immigration, status. Now, these differences were important because they suggested that the text itself contained meaningful agency-specific signals that a classification model could learn. So from our exploratory analysis, we saw both a challenge in the class imbalance and a promising signal in the actual language of the documents. These findings provided the foundation for testing our different model approaches. Thank you.
For training and evaluation, we first divided the document using a family-aware split. A document family means closely related document based on the same underlying form, such as the form itself, its instructions, or a supplement. If we had split the data by individual files, one version could have appeared in training while a closely related version appeared in testing. The model could then benefit from repeated wording instead of showing that it could generalize to a new document family. To prevent this leakage, we grouped the families before splitting and kept each family entirely within one partition. After the eligibility checks, we had 461 training documents, 99 validation documents, and 99 frozen test documents with 0 family overlap. We then handled documents longer than BERT's 512 token limit. Instead of using only the beginning of each document or selecting one random section, we divided the complete text into overlapping windows of up to 512 tokens, with 128 tokens shared between neighboring windows. This helped BERT capture information from across a document without losing important context at the window boundaries. Long documents therefore produced multiple processing windows, but these were not new independent documents. Finally, we combined a window level output to produce one agency prediction for each complete document. After creating the family-aware split, we configured 3 routing methods: fine-tune BERT, Gemini, and Gemini with RAG. BERT was trained for 6 epochs using the settings shown on this part of the slide, and based on validation macro F1, we selected the epoch 2 checkpoint, which was the earliest checkpoint to achieve the highest score of 1. Plain Gemini used a consistent classification setup with 4 possible agency labels. For Gemini plus RAG, we graded embeddings and using ChromaDB to retrieve the most relevant passages from training set only, that is here top 3, and we then gave all 3 methods the same 99 document that we called frozen test document under 10 masked and unmasked conditions, creating 2,970 evaluation cases. The complete unmasked document was the normal condition, while the remaining conditions tested reliability when identifiers or document sections were unavailable. With that setup in place, I will hand it over to my teammate Kleopatra, who will present and compare our results.
Let's start the results with the easiest possible test. A complete, clean document, nothing hidden, nothing removed. There, all 3 methods, BERT, plain Gemini, and Gemini with RAG, hit a perfect 1 on accuracy and macro F1 across all 4 agencies, with perfectly diagonal confusion matrices. So if that were the whole story, you think they're interchangeable. But a newcomer won't always hand you a clean form. They might photograph half a page or black out their personal details first. So that is exactly what we tested next. This is the chart that separates them. We ran all 99 documents through 10 conditions, different slices of each form, from the whole document down to just the beginning, middle, or end. with and without the agencies identifying words masked. That's 990 prediction per method, nearly 3,000 cases in all. Plain Gemini and Gemini plus RAG held a perfect 1 across every condition. It didn't matter what we hid, BERT did not. It stayed above 0.95, but its lowest fell to 0.9587 on beginning only text and dropped on several masked conditions too. So the headline is robustness. BERT is excellent on clean input, but not noticeably more fragile once you remove information, which matters when real inputs won't always be clean. So why did BERT get it wrong? We didn't just report 6 errors and leave it at that. We asked why. Why were the inputs too short? Mostly no. Of the 6, only 1, an SSA forms ending, was genuinely the shortest of its kind. The rest were typical length, so we used an integrated gradient to see which words pushed the model towards its answer. Take this W4V form. Its opening was misclassified as SSA instead of IRS, and both IRS and SSA sit right there as top contributors. The form genuinely is about Social Security recipients requesting IRS withholding. So the document itself is legitimately ambiguous, not a random glitch. And here's what matters. In the working prototype, the first piece of the broader NewStart AI vision, you feed it a document, it classifies the agency, and hands back a short routed guidance message. Here, BERT misroutes an IRS document to SSA. So the user is told their form relates to Social Security and pointed to the wrong agency. The LLM and the LLM plus RAG both route to the IRS correctly. So one classification error isn't abstract. It directly becomes the wrong guidance handed to a newcomer. Finally, plain Gemini versus Gemini with RAG. Across all 990 cases, they tied on accuracy. But plain Gemini used about 4 times fewer tokens, cost roughly a third as much, 15 cents versus 43, and ran slightly faster. For agency classification, RAG added complexity with no measurable benefit. So our recommendation is this. If you want the strongest, most robust performance and an external API is acceptable, plain Gemini is the best choice. But if privacy, local deployment, or no per request fee matter more, BERT is a strong alternative. You just trade away some of that robustness. Thank you.
Our conclusion is not that one model always wins. For this MVP, plain Gemini gave the strongest observed trade-off. It stayed perfect across all 10 conditions while using less time and fewer tokens than the RAG version. BERT remains a strong option when local deployment, privacy, predictable infrastructure cost, or faster routing matters most. And RAG was unnecessary for agency classification, but it may be valuable in the next stage, where a user needs current fees, eligibility rules, required evidence, deadlines, and source-backed answers. The study is limited to 4 agencies. Their S-class is small. Complete form classification reached a performance ceiling, and the generated guidance wasn't formally evaluated. The next step is to add harder and overlapping agencies, stronger and simpler baselines, and a knowledge-intensive evaluation of the guidance layer. Finally, I'd like to thank my teammate and Professor Anna Marbet for their support and guidance. Thank you, everyone.